Hello everyone and welcome to the MathDBase.com Anacast series. I'm your host, John Kisiedu. In this installment in the Developmental Mathematics series, I will discuss addition tactics, part 1, left to right row addition for quicker sums. Though most of us learn to add from right to left, starting with the units column, moving one by one through the columns with higher place value, addition from left to right by rows is much more efficient, partly because it is much more like how we read. For example, adding 313, 145, and 212 can be thought of as three separate problems. Since each of the numbers is in the hundreds, the three addends, the components of the sum, can be separated into columns, each with just their hundreds, tens, and units components. Problem A involves only the leftmost column of the original, the hundreds place. Adding the rows, the sum is 300 plus 100 plus 200, which equals 600. So the sum of the original problem will be at least 600. Using the usual right to left addition method, there is no idea of the size of the total until addition is finished. Problem B involves only the middle column, the tens place. Adding the rows, the sum is 10 plus 40 plus 10 for a subtotal of 60. Problem C involves only the last column, the units place. Adding the rows, the sum is 3 plus 5 plus 2. For a subtotal of 10. The sum of the original problem is equal to the combined sums of problems A, B, and C, 600 plus 60 plus 10, which is 670. In actual use, it is not necessary to rewrite the original problem as three separate problems, but rather only to think of it in a similar way. To solve this problem, you would only have to look at the numbers in successive place values, highest to lowest, either write down or memorize the intermediate subtotals, then add those to find the final sum. Starting at the first row, counting downwards, you could say 300, 400, 600. Then back to the first row, counting tens, 610, 650, 660. Then 663, 668, and 670, counting the units. For example, if we want to add 5,228, 6,936, 7,937, and 8,849, we can add the thousands, 5,000 plus 6,000 plus 7,000 plus 8,000 for a subtotal of 26,000, then add the hundreds, 200 plus 900 plus 900 plus 800 for a subtotal of 2,800 or 2,800, add the tens, 20 plus 30 plus 30 plus 40 for a subtotal of 100 plus 20, finally add the units, 8 plus 6 plus 7 plus 9 for a subtotal of 30. The total is 26,000 plus 2,000 plus 800 plus 100 plus 20 plus 30, which equals 28,950. When adding by rows, it also helps to take advantage of special pair combinations. In summing step 1, you can think 7 plus 8 is 15, plus 5 is 20, plus 6 equals 26,000s. Focus on the main parts of the number. The supplemental parts, the 00 of hundreds, the 000 of thousands, and the 5 zeros of hundred thousands, etc., will follow and attach to the results. In step 2, 8 plus 2 is 10, 9 plus 9 equals 18, then 10 plus 18 equals 28 hundreds, and so on. Using left to right addition, you can get a good idea of what the final sum is long before the problem is even finished. In the first example, adding 313, 145, and 212, we saw pretty early that the sum would be at least 600. Considering the main parts of each addend, the 13 and 12 in 313 and 212 are each close to 10, and the 45 and 145 is close to 50. Combining these, the total is in the neighborhood of 670, 600 plus 10 plus 10 plus 50. It is possible to select how refined an estimate you want. In the second example, in which we added 5,228, 6,936, 7,937, and 8,849, with a relatively quick look, you can determine that the sum is over 26,000. Taking a closer look, 228 is close to 200, 936 and 937 are both close to 900, and we can estimate 849 at either 800 or 900. Putting these four estimations together, we have between 2,800 and 2,900. The 28, 36, 37, and 49 together will add less than 140 to the result. With all of this additional information, you can say that the entire sum will be no more than 29,000. Writing it all down like this may make it seem like a long process, but with practice, estimates on the low and high ends can be determined in seconds. The rule of thumb for estimations is if the number ends in 4 or less, you round down. If it ends in 5 or more, you round up. Rounding can also be used at higher place values. 1,250 can be rounded to 1,300 to the nearest hundred, and 1,227,000 can be rounded to 1,200,000 to the nearest 100,000. For example, we can give some estimates of the sum of 5,384,113 and 4,213,464. A quick glance and an application of the rounding rules indicates that the sum will be in the neighborhood of 9,600,000. Rounding 384,113 up to 400,000 and 213,464 down to 200,000. Rounding again, taking the 100,000s, 10,000s, and thousands places into consideration, a better estimate is 9,597,000. The actual sum is 9,597,577. So our quick glance estimate was pretty close.